Welcome to the Wolfram Language in Section 16 of Fast Introduction for Programmers. This section is about procedures and procedural programming in the Wolfram Language. Procedural programming involves organizing a program as a sequence of steps. For example, here is a procedural program with the steps separated by semicolons. A sequence of steps separated by semicolons like this is called a compound expression. Here is another procedural program. This program uses an assignment to save a number as the value of a variable, and then uses that variable in the next step. The assignment in this program has the side effect of assigning a global value to the variable, which could conflict with other uses of that same variable elsewhere in this Wolfram Language session. One way to prevent such conflicts is to remember to clear values that are no longer needed. In most cases, though, a better solution is to localize these variables, which can be done using the module function. Localizing the variable like this prevents the program from assigning global values to variables. The module function does what is called lexical scoping, which means that it localizes the names of variables as well as their values. For situations where the variable already exists and you only want to localize the value of the variable, you can use the block function, which does what is called dynamic scoping. For example, this input gives a formula with a variable x, and this uses the block function to evaluate that formula with a local value for x. Afterwards, x is left without a value. For localizing variables, there is one other function called dynamic module, which has the separate specialized purpose of localizing variables in dynamic interactive controls. To demonstrate a situation where localization of dynamic variables might be important, this input gives a slider for controlling a variable x, and then copy and paste to get a second copy of that slider. Since the variable is not localized, both sliders control both dynamic values of x. The dynamic module function localizes the controlled variable so that each instance of the slider controls a separate local variable, which can be seen by repeating that process of creating a slider and a copy of the slider, and observing that with dynamic module, each slider controls a separate localized variable. Often it is useful to transfer data out of a program or transfer control from one step in a program to another. One way of transferring data within a program uses the sow and reap functions. For example, this calculates the sum of I squared for I ranging from 1 to 10, and this uses sow and reap to give the same result and to also collect the values of the variable I that come up during the calculation. One way of transferring control within the steps of a program uses a pair of functions called throw and catch. For example, here is a program with 3 simple steps, and here is a modification of that program that uses throw and catch to transfer control out of the program after the second step. The Wolfram language also includes basic test and conditional operations. Tests are operations that return true or false. For example, this returns true because 7 is greater than 5. Here is a test that uses 2 ampersand characters for the logical AND operation. This returns true because both statements in the logical AND are true. Conditionals are functions that do different things depending on the outcome of a test. One basic conditional is the if function. In the Wolfram language, if is just another built-in function. This example returns A because the first argument in the if function is true, and this returns B because the first argument in the if function is false. You can find more information about procedural programming in the Wolfram language by choosing Wolfram Documentation under the Help menu to bring up the Documentation Center page, clicking the Core Language and Structure button, and choosing Procedural Programming in the menu that comes up, which brings up this page with links to the full range of procedural programming functions.